Hello, this is a past paper of 2019, GCSE Feb March, component 4.2. Question number 1, define acceleration. We know that rate of change of velocity is called acceleration. Next part, describe the motion of the cyclist in the time between 0 to 15. If you look at figure, distance, time, you can understand that from 0 to 15, a slope of the figure is increasing, so gradient increasing, so it means increasing a speed. Between 15 to 30, constant speed because a slope is constant. And between 30 to 40, a slope is decreasing, it means decreasing a speed. Next part. Calculate for the 40-second journey the average speed. We know that the average speed is equal to total distance over time taken. So total distance is 300 and time taken is 40. If you divide, you will get 7.5 meters per second. What is maximum speed? We know that if you look at figure, between 0 to 15, a slope is increasing. Between 15 to 30, a slope is constant and then decreasing. So maximum speed happens between 15 to 30 seconds. That's why you can find a slope of line between 15 to 30 to get maximum speed. So a slope is rise over run. Rise is 250 minus 70 and run is 30 minus 15. So the final answer will be 12 meters per second. Question 2. State one advantage and one disadvantage of using a wind turbine as a source of electrical energy. So advantage is no pollution of air, and the second one will be no fuel costs. And disadvantage, it is causes a lot of noise pollution, and you know that wind is not always blowing. So you can write one of them to get 1 mark. In second part, it is said that calculate the mass of air that passes through the circular area swept caught by the blades in 1 second. So we know that density is mass over volume. So what is mass? Density times volume. So mass is equal to density times volume. Mass is density is 1.3 and volume is 24,000. So the answer will be 31,000 kg. Part 2, kinetic energy of the mass of the air that passes through the area swept out by the blades. So kinetic energy is equal to 1 over 2 mv squared. 1 over 2, mass is 31,000 and speed is 16. So if you substitute, you will get 3.97 times 10 to the power 6 joule. Next part. Suggest why some of the kinetic energy of the air that passes through the circular area swept out by the blades is not converted into electrical energy. You can say that some air passes through blades, or you can say not all kinetic energy of air transfers to blades. So you can write one of them to get 1 mark. Question 3. An object is moving in a straight line at constant speed. State 3 ways in which a force may change the motion of the object. So you can write increase the speed, decrease the speed, or change direction. Part B, figure 3.1 shows an object suspended from two ropes. The weight of the object is 360 Newton. The magnitude of the tension in each rope is T. In the space below, determine the tension by drawing a vector diagram of the forces acting on the object. State the scale you have used. Okay. First of all, angle between tensions between these two ropes will be 180 minus 45, because you can see that you have 45 here and 45 here. So if you subtract from 180, you will get 90 in the middle between two ropes. So we know that this system is stationary, so it means it is in equilibrium. That's why resultant force is 0. So we draw a line with the same magnitude in opposite direction with the weight. So if our scale is 100 Newton is 1 centimeter, that's why 360 Newton weight is equal to 3.6 centimeter. So you can draw 3.6 centimeter downward and also upward 3.6 centimeters. Then you can make a parallelogram, and when you measure T by ruler, you will get 2.55 centimeter, which is 255 Newton in your, because if you convert in your scale, 100 Newton is 1 centimeter, that's why 2.55 centimeter will be 255 Newton. This is one way to do this question. Second way is that this force is 360. Okay, there are two forces upward. One of them is here, another one is here. So these two forces must be equal to 360, because T will be same in two ropes. That's why if this is 360, one of them is 180 and this one also is 180 Newton. Then you can use sine theta equal to (180) divided by T. So you can find T 180 divided by sine theta, which is sine 45. Sine 45 again, you can get 255 Newton. So this is the second way to do these questions. Next question. Figure 4.1 shows a mercury barometer. The tube containing the mercury is vertical. The height indicates the value of the atmospheric pressure. State what is contained in the space labeled S. So it is vacuum or mercury vapor. Next part. On a particular day, the atmospheric pressure is 1.02 times 10 to the power 5 Pascal. Density of mercury is 13,600 kg per meter cube. Calculate the value of H indicated by the barometer. So you know that pressure is equal to rho GH. Rho is density, G is 10, gravitational acceleration, and H is height of tube, which is containing mercury. So you will get H is 0.75 meter if you substitute data. Next part. The tube containing mercury is now tilted so that it makes an angle of 10 degrees with the vertical. After tilting, there continues to be a space above the mercury in the tube. State and explain whether the vertical height of mercury in the tube is smaller, the same, or greater than the value calculated in A, part 2. So the answer is clear. You can say the same vertical height. Why? Because pressure due to column of liquid depends on vertical height. That's why it has same vertical height. Another mercury barometer in the same room at the same time shows a lower value of H than the barometer in A. Suggest and explain a reason for the lower values. So we can say that air is present above the mercury in the tube, which causes a downward pressure on the mercury. That's why it shows a lower value of H. Question 5. State the values of the fixed points of a temperature scale. So we know that fixed point of a thermometer is 0 degrees Celsius and 100 degrees Celsius. 0 degrees Celsius is for melting point and 100 degrees Celsius for boiling. The graduations on liquid and glass thermometer are equally spaced. For the equal spacing of the graduations to be correct, state an assumption that is made about the liquid in the thermometer. So assumption will be linear expansion. So liquid should have linear expansion. An assumption that is made about the structure of the thermometer. So a tube should have constant diameter, or you can say constant thickness. Liquid in glass thermometer A has a greater range than liquid in glass top thermometer B. State one way the design of thermometer A is different from thermometer B. So in this part you can say that A is longer than B, that's why it has greater range. Or you can say A has a smaller bulb, so this can be because of greater range. Liquid in glass thermometer C has a greater sensitivity than liquid in glass thermometer D. State one way the design of thermometer C is different from thermometer D. So you can say that C has a narrower or thinner tube, or you can say that C has a larger bulb, or you can say that C contains alcohol instead of mercury. So alcohol is more sensitive comparing to mercury, that's why you can write one of them. So if you write C has a narrower tube, you can get 1 mark. Or if you write C has a thinner tube, you can get 1 mark. Or has a larger bulb. Part C. In the space provided, draw a labeled diagram of a thermocouple thermometer. So you know that a thermocouple thermometer has 2 junctions, hot junction and cold junction, connecting with 2 wires, 2 dissimilar metals. So one of them can be copper and the second one will be iron. And we connect 2 junctions to the voltmeter. So we need 1 voltmeter, 2 junctions, 2 dissimilar metals, which can make a thermocouple thermometer. Suggest when a thermocouple thermometer is more suitable than a liquid in glass thermometer, because thermocouple thermometer has a high range of temperature. That's why it is more suitable. Next question. An electrical heater is placed on the floor of a room in a house. the heater is switched on. State the main process by which thermal energy is transferred to the air in all parts of the room. So it is clear, it is convection. The heater has a power of 1.5 kilowatts. The air in the room has a mass of 65 kg. A specific heat capacity of air is 720 joule per kg degree Celsius. Calculate the time it takes for this heater to raise the temperature of the air in the room from 8 degrees Celsius to 15 degrees Celsius. We know that thermal energy or heat is equal to mc delta theta, which is equal to PT, power times time. So in this question, examiner mentioned power, that's why instead of Q you can write PT. So if you substitute numbers, time, you can get time 220 seconds. State two reasons why the calculated in B is smaller than the actual time taken to raise the temperature of the air in the room from 8 to 15. So one reason can be thermal energy is conducted through walls or floor. And the second reason, you can say that the heater warms floor, walls, and windows. That's why whatever you get in part B, first part, will be different. Question 7. In figure 7.1, the small circles represent molecules. The arrows refer to the change of state from the arrangement of molecules on the left to the arrangement of the molecules to the right. Sorry. Complete the following by writing solid, liquid, or gas in each of the blank spaces. Change of state X is from, so X is solid, and to liquid. So X is solid, and right part figure is liquid. For next part, part 2, change of state Y is from liquid to gas. Next part, explain in terms of the forces between their molecules why gases expand more than solids when they undergo the same rise in temperature. So we know that gas molecules have weak forces of attraction between them. That's why they expand more easily and gas molecules move farther apart. That's why gases expand more than solid. Next part, part C. A cylinder of volume 0.012 meter cube contains a compressed gas at the pressure of 1.8 times 10 to the power 5 Pascal, 10 to the power 6 Pascal. A valve is opened and all the compressed gas escapes from the cylinder into the atmosphere. The temperature of the gas doesn't change. So this is a key point for this kind of questions. Temperature of the gas doesn't change. It means this is Boyle's law. Calculate the value that the escape gas occupies at the atmospheric pressure of 1 times 10 to the power 5 Pascal. We know that in Boyle's law, pressure times volume is constant. So multiply of pressure and volume will be constant. So PV is constant. So it means P1V1 in first condition is equal to P2V2 in second condition. So in first condition, we have 1.8 times 2 power 6. This is P1 times V1 is 0.012 meter cube. In second situation, P2 is 1 times 10 to the power 5 Pascal times V2. So if you calculate, V2 will be 0.012 216 meter cube. This is a second situation. Now, what is the volume of escape gas? For volume of escape gas, you have to subtract the first volume from the second volume. So in second situation, you will get 0.216, which is equal to nearly, it is equal to 0.22 meter cube. Subtract from 0.012, you will get 0.21 meter cube. So this is volume of escape gas. Next question. Figure 8.1 shows parallel wavefronts of a light wave in ice. The wavefronts are incident on a boundary with air. Okay. The speed of the light wave in air is 3 times 10 to the power 8 meter per second. The refractive index of the ice is 1.3. On figure 8.1, draw the wavefronts of the wave that pass into the air. Draw arrows to show the direction of travel of the refracted wave. Label the angle of incidence I and the angle of refraction R. Okay. First of all, you should draw normal line. So these red lines are normal lines which are perpendicular to boundary. So I draw 5 normal lines at the point that wave incident with boundary. So N can show normal line. Then refracted ray goes away from normal comparing to incident ray. Why? Because ice is denser comparing to air. That's why when wave from denser medium goes to less dense medium, it goes away from normal. So I should be larger than R. So it should be clear. Angle of I should be more than refracted angle. And refracted rays must be parallel, but they must go away from normal comparing to incidence angle. And the green arrow is for second part. For this part, the green arrow is for part 2. It shows direction of travel of the refracted wave. And you can see that I is incidence angle. It is an angle between normal line and incidence ray. And R is refracted angle. It is an angle between N and refracted ray. So important notes: angle between normal and incidence ray is I. Angle between normal and refracted ray is R. Direction of travel of the refracted wave is perpendicular to refracted wavefronts. So this angle must be 90. Next part, calculate the speed of light wave in the ice. So you know that refractive index is equal to C divided by V. C is a speed of light in air, which is 3 times 10 to the power 8, and V, a speed of light in medium. So in this question it is unknown. So V is equal to C over N. When you calculate, you will get 2.3 times 10 to the power 8 meter per second. Question 9. Figure 9.1 shows current potential difference graphs for a resistor and for a thermistor. Calculate the resistance of the thermistor when the PD across it is 7 volt. So from figure, when V is 7 volt, you can find I. So 7, when V is 7, then you can find I. I will be 4.6. Okay. Now Ohm's law formula, R is equal to V over I. So V is 7, I is 4.6. If you divide, resistance will be 1.5 ohm. Next part. In table 9.1, tick the boxes that indicate the effect on the resistances of the resistor and of the thermistor when the PD across them is increased from 0 to 7 volt. If you look at figure 9.1, you can see that a slope of current against voltage of resistor is constant. That's why resistance is constant. Why? Because a slope is equal to, a slope of this figure is equal to I divided by V, which is equal to 1 over R. So what does it mean? It means when a slope is constant, R is constant. But for thermistor, if you look at graph for thermistor, curve for thermistor, a slope is increasing. A slope of IV against V is increasing. When a slope is increasing, R of thermistor decreasing. Why? Because based on this formula, a slope is equal to 1 over R. So it means when a slope increasing, R decreasing because of reciprocal relationship between a slope and R. That's why R of thermistor decreasing. So you can choose for resistor, resistance is constant, and for thermistor, resistance decreases. So tick these two rectangle or boxes. Part C, the thermistor and the resistor are connected in parallel to a 7 volt supply. Calculate the current from the supply. Okay, we know that in parallel you should add currents. So I1 plus I2. Because they have same potential difference, so current will be same for them. So if you look at figure, for both of them, when V is 7, I is 4.6. That's why you should add 4.6 plus 4.6, which is 9.2 ampere. For second part, the energy transfer from the supply in 5 minutes. So energy is equal to PT, power times time. So instead of power, you can write IV, IVT. If you substitute, you will get 9.2 times 7 times 5 times 60. This is time. Change it to seconds. You will get 19,320 joules. Question 10. The electrical energy produced by a power station is transmitted over long distances at a very high voltage. Explain why a very high voltage is used. If voltage is very high, then current is very low. So power loss is low. If current is very low, then we don't need expensive cables, or we don't need very thick cables. So when current is very low, thinner or cheaper transmission cables can be used. That's why they don't use low voltage when they are transmitting electricity from city or from power station to cities. That's why they use high voltage, because when they use high voltage, then current will be low and power loss is very low. Thermal energy wasted, wasted very less comparing to low voltage. And when the current is very low, you can use cheaper cables. Next part. Figure 10.1 represents the transformer. The primary has 4,000 turns and input is 120 volt. Secondary has 9 volt output. Calculate the number of turns in the secondary coil. So turns ratio for transformer is Vp divided by Vs is equal to Np divided by Ns. So Vp is 120, Vs is 9 volt, Np is 4,000 turns, and Ns is unknown. If you calculate, you will get 300 turns. So number of turns for secondary coil is 300. State a suitable material for the core of the transformer. So it is iron. Question 11. One isotope of iridium 194 is represented by IR 19477. This isotope decays by beta emission to a stable isotope of platinum, Pt. Complete the nuclide equation for this decay. So we know that beta is 0 and -1. So if you write 0 and -1 for beta, then you should use conservation of mass and charge. For the upper part, you should write conservation of mass. So you can write it 194 is equal to, for example, x plus 0. So what is x? 194. So this is this number. And for atomic number, you should write conservation of charge. So you can write it again, you can write it 77 is equal to y plus -1. So y will be 88. So sorry, 78. Y is 78, which you can see here. So you should use conservation of mass and charge to get atomic mass and atomic number. Next part. Half-life of iridium 194 is 19 hours. A sample has an initial count rate of 1,100 counts per minute. Calculate the count rate for the sample after 38 hours. So one formula which is not in your syllabus, it is easy to remember, that's why I wrote it here. T time is equal to number of half-life times one half-life. So T is equal to NT. So time is 38 hours, number of half-life is N, and half-life is 19 hours. So number of half-life will be 2. Then count rate is 1,100 initially. After one half-life, what is remaining? Count rate changed to 550. And again, after one half-life, changed to 275. So after two half-life, this is not one half-life and this is second half-life. After two half-lives, count rate will be 275 counts per minute. Next part. State two ways in which gamma emission differs from beta emissions. Gamma emission is electromagnetic waves. They are uncharged, they don't have mass, and they have long range in air. Beta emission is electron, negatively charged, they have mass, and they have shorter range in air. So, to know more about the difference between gamma emission and beta emission, I also transfers this answer, the difference between gamma emission and beta emission, from the past paper of Cambridge, market scheme of past paper. So you can see that the difference between gamma emission and beta emission if you need more about them. Thank you very much and goodbye.